Imagine looking up at the night sky. Among the countless stars, one presence dominates: the moon. It is more than a glowing disk. It is Earth's silent twin, a stabilizer, and a witness to our planet's entire history. Unlike most planets, Earth has a moon that is unusually large compared to its host, about 1/4 the size of Earth itself. This oversized companion acts like a cosmic anchor, keeping Earth's tilt steady and our seasons predictable. Without it, our oceans would surge unpredictably, our climate would swing wildly, and life might never have found the balance it needed to thrive. The moon's influence is subtle yet profound. Its gravitational pull tugs at Earth's oceans, sculpting tides that shape coastlines, ecosystems, and even human culture. Ancient civilizations built calendars around its phases, farmers planted by its rhythms, and poets wrote by its glow. But beneath this cultural significance lies a deeper truth. The moon is a stabilizer of chaos. Compare this to Mars, where two tiny moons, Phobos and Deimos, circle like restless shadows. They are too small to steady Mars' tilt, leaving the planet to wobble over millennia. Mars' climate swings from ice ages to fiery deserts, a world of instability. Earth's moon, by contrast, locks our planet into a rhythm that makes life possible. This unusual size and influence raise questions. Most moons are fragments, captured asteroids or small companions. Jupiter's Ganymede, though larger than Mercury, is dwarfed by Jupiter itself. Earth's moon is unique in its proportion, hinting at a violent origin. Scientists believe it was born from a colossal impact when a Mars-sized body collided with Earth, ejecting debris that coalesced into the moon. In this sense, the moon is not just a companion. It is Earth's child, forged from the same material, carrying the scars of our planet's earliest days. And yet, the moon is not static. Its orbit slowly drifts away from Earth, about 3.8 centimeters per year. In the distant future, tides will weaken, eclipses will vanish, and Earth's rhythm will change. The moon is both a guardian and a reminder that nothing in the cosmos is permanent. Compare this to Pluto and Charon, locked in a mutual embrace, orbiting each other like eternal partners. Their dance is frozen, while Earth's moon slowly slips away. The contrast reveals the diversity of cosmic relationships, each shaped by gravity's invisible hand. As we begin this journey, the moon stands as Earth's twin, anchor and storyteller. It is the reason our world is habitable, the reason our nights are illuminated, and the reason our seasons are steady. But its story is not only about influence. It is also about scars. Look closely at its face and you see a frozen battlefield, a record of cosmic violence preserved for billions of years. The moon's surface is a diary of impacts, untouched by erosion, untouched by time. And so as we move deeper into this documentary, we leave behind the question of why the moon is so big, and turn to the question of what its scars reveal. So why is Earth's moon so big? And what scars does it carry? The answers lie written across its cratered face. Look up at the moon and you see a face carved by violence. Every crater, every basin, every jagged ridge is a scar from an ancient collision, preserved for billions of years. Unlike Earth, where wind, rain, and tectonic shifts erase the past, the moon has no atmosphere, no weather, no flowing rivers to soften its wounds. It is a geological diary, frozen in time, a battlefield where asteroids and comets left their mark and then moved on. Each impact is a chapter, each scar a sentence in the story of the solar system's chaotic youth. To gaze at the moon is to gaze at history itself, written in stone. Compare this to Venus, Earth's so-called twin. Venus once bore craters too, but its surface is constantly reshaped by volcanic eruptions. Rivers of lava have resurfaced the planet, erasing most of its ancient wounds. Where the moon remembers, Venus forgets. Mercury, closer to the sun, tells yet another story. Its battered surface is similar to the Moon's, but its magnetic field and proximity to solar radiation have sculpted its scars differently. Mercury's craters are twisted by solar storms, while the Moon's remain untouched, silent witnesses to impacts that shaped not only itself, but Earth as well. The Moon is unique in its permanence. It holds onto its past, refusing to let time erase it. The largest scars are the Lunar Maria, vast dark plains formed when ancient impacts cracked the crust and allowed molten rock to flood the surface. These seas of basalt are visible even to the naked eye, shaping the familiar man-in-the-moon pattern. They are not seas of water, but seas of fire, reminders that the Moon was once geologically alive. Compare this to Mars, where volcanoes like Olympus Mons tower higher than any mountain on Earth, reshaping the planet's surface with eruptions that dwarf anything the Moon ever experienced. Mars' volcanic scars are colossal, but the Moon's are eternal. Its maria remain frozen, black mirrors of a fiery past. The Moon's scars also tell us about Earth. Many of the impacts that struck the Moon would have struck Earth too, but Earth's atmosphere burned them away or erosion erased them. The Moon is Earth's shield and archive, recording the blows that might have devastated our planet. Without the Moon, we would not know the scale of the bombardment that shaped the early solar system. Compare this to Jupiter, whose massive gravity acts as a cosmic vacuum cleaner, pulling comets and asteroids into its orbit and protecting the inner planets. The Moon plays a smaller but similar role, absorbing impacts that might otherwise have struck Earth. Its scars are not just its own. They are ours too. And yet, scars are only skin deep. Beneath the cratered shell lies another story, one hidden from view. The Moon's interior is quieter, stranger, and less understood. Its small, partly molten core contrasts sharply with Earth's dynamic iron heart. This difference explains why the Moon has no magnetic shield, why its surface is exposed to solar radiation, and why its scars remain untouched. To understand the Moon fully, we must look beneath the surface, into the secrets of its interior. Scars tell us what struck the Moon, but not what lies beneath. To uncover its deeper story, we must journey into its hidden heart. Beneath the Moon's cratered shell lies a quieter, stranger story. One hidden from view, but essential to understanding why the Moon is the way it is. Its interior is not the roaring furnace of Earth's iron heart, but a subdued, almost sleeping core. Scientists believe the Moon's core is small, only a fraction of its total volume, and partly molten. This limited activity explains why the Moon has no protective magnetic shield, no plate tectonics, and no volcanic reshaping in the present day. It is a body that has cooled, slowed, and fallen silent. Where Earth's core churns with molten iron, generating a magnetic field that shields us from solar radiation, the Moon's heart whispers instead of roars. This silence has consequences. Without a magnetic field, the Moon's surface is exposed to the full force of solar winds and cosmic rays. Its soil, the fine powder called regolith, is infused with particles from the Sun, a record of space weather written into dust. Compare this to Ganymede, Jupiter's largest moon, whose molten core generates a magnetic field strong enough to carve auroras into its icy surface. Ganymede proves that moons can be geologically alive, their interiors dynamic and protective. The Moon, by contrast, is a relic of cooling, a body that has lost its shield and now bears the scars of exposure. Yet the Moon's interior is not entirely dead. Seismic instruments left by Apollo astronauts detected moonquakes, tremors that ripple through its crust. Some are caused by tidal forces from Earth's gravity, others by thermal expansion as the Moon's surface warms and cools. These quakes remind us that even a quiet heart can stir. Compare this to Mars, where recent missions have detected Marsquakes, evidence that its interior is still shifting, though slowly. Both worlds show that silence is not absolute. Beneath the surface, there are whispers of motion, echoes of ancient energy. The moon's interior also tells us about its origin. Its composition is strikingly similar to Earth's mantle, supporting the theory that the moon was born from a colossal impact. A Mars-sized body collided with Earth billions of years ago, ejecting molten debris that coalesced into the moon. This shared chemistry explains why lunar rocks resemble Earth's, yet lack the heavier metals concentrated in Earth's core. The moon is Earth's child, forged from its outer layers, carrying the fingerprints of a violent birth. Compare this to Triton, Neptune's captured moon, whose retrograde orbit suggests it was once a wandering body pulled into Neptune's gravity. Triton is an adopted child. The moon is a blood relative. Understanding the moon's interior is not just about science, it is about survival. Future explorers may tap into its resources, mining its crust for oxygen, metals, and even helium-3, a rare isotope that could fuel fusion reactors. The moon's quiet heart may yet power humanity's future. Compare this to Io, Jupiter's volcanic moon, whose furious eruptions make it the most geologically active body in the solar system. Io's interior is a furnace, the moon's a fading ember. Both extremes remind us of the diversity of worlds, each with its own destiny. As we leave the moon's interior behind, we realize that its silence is not emptiness, but memory. It is a body that has cooled, preserved, and recorded the past. Its quiet heart explains its scars, its exposure, and its permanence. But if the moon's heart is subdued, what about its breath? The thin veil of atmosphere that separates worlds of silence from worlds of storms.